Hello, this is Usama Fayyad. I'm the inaugural director of the Institute for Experiential AI at Northeastern University. And I'll be sharing with you a presentation, some of the thoughts on AI and the implications for the Commonwealth. Really, this is about kind of understanding what we're talking about and then figuring out how to create the right ecosystem. AI has become mainstream, and probably the biggest area visible to everybody is unlocking your phone with your face, launched by Apple. The field itself has a deceptively simple definition. It's about the use of computers to simulate human intelligence. Defining intelligence has been and remains an open problem to this day, from the days of Alan Turing and before, in fact. Till now, we can't define it. Even simpler notions like common sense reasoning have been a challenge. We're going to talk about machine learning, which is a subset of AI concerned with machines modifying or learning behaviors by examining data and using that training data to kind of predict outcomes or behave in a certain way. The field has gone through a lot of excessive hype. The hype cycles before led to two AI winters. That means there was a cut in funding. People were denying they had anything to do with AI because the field didn't deliver on all the expectations that were set by the excessive hype. The first winter happened in the mid-70s. The second happened in the early 90s, in fact, as I was graduating with my PhD. The hype continues today. We hear a lot of things. Elon Musk continues to be very outspoken, and I wish he wouldn't be so much. For many years, he claimed that we would have autonomous driving the next year. This has been going on since 2017. Most recently, he predicted that we're going to have an AI that's smarter than the smartest human by the end of this year, 2024. I think we're still pretty far from that today. But that hype usually doesn't help anybody and sets expectations that get us in trouble. Everybody keeps saying, well, we're all going to be useless, jobless, brainless, and people are worried about China 2030 program. Just like back in the early 90s, they were worried, in the 80s, they were worried about the Japanese fifth generation systems program. We do have real reasons to worry about China. They have a very competitive approach to ours, different, but very competitive. Machine learning, however, has survived both of those winters and, in fact, prospered through them. Not because we developed amazing algorithms. There's been a lot of developments in a lot of areas of machine learning, but really they haven't been that major. Really, what has been major is we had a lot more data because of the internet, because of digitization. There was just a lot of data around, and we could leverage that. And that saved us from having to basically figure out how intelligence worked. And we used machine learning as a shortcut to solve problems. So in a quick summary, AI, there's a subfield of it called machine learning. And a subfield of machine learning is generative models or generative AI, which we will talk about some in this presentation. If you look at it from an applied perspective, how is AI being used in the real world? You'll see a lot of what's called supervised learning or predictive AI. This is more of the classical machine learning under AI, where I tell the algorithm exactly what the outcome should be with each data point. And the point is to learn from this labeled data. There's an unsupervised learning variety, which says, well, we don't label the data, but we will group the data by similarity. And maybe the similarity groups give us some insights, customers who look alike or events that look alike, etc. And we can discover some interesting groupings. Much smaller in application area, even than those two, is generative AI. So it's getting maybe 90% of the mind share, but it's still a very small percentage of the deployed system. So always keep in mind that predictive AI is around and can deal with a lot of problems. And then, of course, there's a lot of the varieties of the various ways to do learning. much smaller applications and so forth. One thing I'd like to remind everyone is that this is not about training an algorithm. After you train the algorithm, you have to go through a lot of cycles of basically challenging it, fine-tuning it, catching all the corner cases and so forth. In generative AI, this is called fine-tuning, and we will talk about that a bit later. There's two lost themes when people do AI. The first is that data is absolutely essential. Now, that one is fairly well known to practitioners of AI and so forth. The second is that human intervention is essential. Continuous course correction, continuous feedback to make sure the AI is on track and not deviating happens a lot more than you think. Data is essential means you have to capture, it's simple to say, but in reality, you have to capture the events, the outcomes, and the context. Much harder to do in reality than to just say it. For interventions, we have to capture the guidance, all the corrections that happen, typically by humans for the machine, and of course, the context of why these corrections happened and so forth. Most organizations, by the way, struggle with just getting the basics of data and making data work as an asset. The AI haves, companies like Google, OpenAI, Microsoft, Amazon, etc., understand this very well. And they, in fact, have many armies of generalists who provide the common sense reasoning and the feedback to the algorithms. As an example, Google search relies in its core in the ranking engine on something called MLR. MLR stands for machine learned relevance. And that engine is retrained 3 to 4 times a day based on data coming from search editorial teams. These are teams whose job is to say, hey, this is the wrong result, or move this down, move this up. Oh, this is a meme. It means something completely different. Stuff that's very hard for the algorithm to get, but humans can get at it fairly reliably. And that has been happening for 20 years, multiple times a day, every day. And that's how you get the magic of a Google search engine that works in an amazing way. So that human in the loop is there even when we think about systems that are autonomous and going on their own. The question now is, in companies, in organizations, how do we capture all that IP of how we do our business, how we service our customers, etc.? That's a much harder challenge. Recognized by a lot of business leaders. I quote Jamie Dimon here in his letter to shareholders in April 2023. He mentioned the word data 27 times, bragged about 300 use cases of AI. In his recent letter of April 2024, he actually talked about AI being like the steam engine revolution and bragged about 400 use cases for AI at JP Morgan Chase. Of course, there's many challenges here. Fairness and bias in algorithms when you start relying on data to drive AI, and that's the only AI that works, is a big deal. Some decisions are much more consequential than, say, targeting ads, an industry I was involved with. If I serve the wrong ad to the wrong person, or if I target somebody with a lot of ads that may not be relevant, that is not so, it's not great, but it's not horrible. You can't do that with financial decisions, with medical decisions, with many decisions of consequence. The problem is algorithms have little to no reasoning capability, and therefore the way to recover and mitigate by the algorithm is hard, further needing human intervention. Modeling complex decisions is a hard problem. The technology also, something to worry about, enables kind of deep intrusions on privacy, on civil rights, and so forth. We also know, especially with generative AI that we'll talk about in a second, it is unstable, meaning when I see a situation that I haven't seen before, what we know about Gen AI is it will generate an answer that is pretty much random and sometimes really strange. And that's of course poses a danger and drives us to kind of worry about these situations. The dependency on data is big, like we said before. But good training data is extremely expensive to get, especially if you have to label it, and you have to label it reliably with quality. So that's an expensive job. Just collecting and managing that data is a hard challenge for most companies. And that's an opportunity for us that I'll talk about in a second. Data is growing exponentially with digitization, with cloud and IoT, so we have it everywhere. But grabbing it, manipulating it, making it available at that fine granularity is a difficult problem for most companies. So we must capture the data. It's there. The majority of the data, by the way, in any organization is unstructured. Most of database systems are designed to capture structured data. Most analytical data warehouses are designed to support human decision-making, which basically requires a lot of roll-ups or aggregation and summarization and charts. That is exactly not what algorithms need. They need very detailed data at a granularity that is useless for humans, but absolutely necessary for algorithms. So what does this mean for us in the Commonwealth of Massachusetts? Well, can we capitalize on the fact that we know that data is one of the essential and lasting assets? So do we build an approach, a system, a framework, and regulation that allows us to capture these data and the human interventions systematically, enabling companies to basically be able to capture this data and therefore close the machine learning loop and therefore enable AI. That would be unique because that is a difficult problem for everyone. And only the big AI haves basically do this today. And they only do it in very specialized settings. So can we come up with a way, a platform, an approach, a mechanism, a service that enables our companies in the Commonwealth to capture data? Once you capture data, and you figure out the regulation around sharing it, around putting it together in usable formats and so forth, we will create an ecosystem that will attract all the AI players and that will enable a lot of new AI players and will also fuel our research industry and our educational system and so forth. So a great opportunity. Within the Institute for Experiential AI at Northeastern, this is something we've recognized early on. We have a focus on use-inspired fundamental research where the application, the domain problem is a key ingredient here. It helps us test our hypotheses and the validity of our research. It helps us set an agenda that is driven by making the research work on real problems. And it kind of allows academia to start contributing because most of the contributions in AI in the past 15 years have come from companies because the companies have the data and they have the problems. Academia has been kind of relegated to dealing with toy problems and kind of classroom type problems, which is a huge limitation. And a lot of the advances, especially in generative AI, have come from kind of real data and real situations. Experiential AI is our code word for AI with the human in the loop, because we actually believe that both kind of capturing the right data and having human guidance and human feedback, what we call human assistant AI and AI assisted human intelligence, is the right interaction metaphor for us. That also helps us engaging and solving problems and creating an experiential education for our students so that when they graduate, they actually have a taste for what it takes to do AI in the real world, something that's very missing. Before joining Northeastern, I was running a company that hired a lot of data scientists. And when I hire a fresh grad data scientist, the typical experience, the first year to 2 years are useless because that data scientist thinks they picked up a lot of bad habits in the classroom. They think that all they have to do is hack a data with an algorithm and they'll get an answer. Reality is you have to understand the context. You have to understand the constraints. You have to understand the data itself is a subject of suspicion and doubt, meaning maybe half the data is missing or 1/3 of it is wrong. What do you do in those cases? How do you fit it in the business? How do you not break regulations? How do you not create biases and so forth? So that is why we had our focus on experiential AI, and our beliefs are human intervention not only is a must, but is a great opportunity to capture a lot of IP that today doesn't get captured. And then it gets encoded in an AI that helps the company, the organization do its business better, faster. And that's very valuable. So many questions on AI strategy would revolve around, are you capturing the right data? Are you closing the loop with machine learning and data science? Do you know where to use predictive AI versus generative AI? What gives you the highest competitive advantage, or what are the big game changers? And how do you acquire, train, and retain the right talent? That brings us to the second opportunity here. What is our talent strategy in the Commonwealth, right? What I can tell you for sure is through necessity, we've been developing a whole bunch of literacy and awareness educational programs, AI business usage, because a lot of our partners need to figure out how do their employees use it, AI technical uses for the technical team, technical in-house expertise, executives and leaders need to understand the technology, policies, regulation, and law. We offer some of these, especially B, C, and D, in what we call an experiential mode, where we believe the best way for people to learn in the workplace is by actually doing the learning by working on their problems. So you can see how the AI does it, and you can see how you do it, and you compare them side by side, and that's when it becomes very relevant, and you pay a lot more attention to it. The questions here are, do we build in the Commonwealth the best educational programs that essentially equip our companies and our organizations in the best possible way and bring everybody here to kind of participate in that ecosystem where the talent is trained and retained? Do we offer the right environment here for startups to hire the right talent, for companies and organizations that offer the services to be able to grow and maybe build the best upskilling program in the nation right here in Massachusetts, as an example. So let's talk about generative AI, right? Generative AI is about the generation of text, images, etc., from a textual or multimodal prompt. Typically, these models, we call them stochastic parrots, because one of the things I'd like to assure you of is, even though they sound eloquent, they don't understand what they're saying. They're just basically doing autocomplete on steroids, driven by a very large, deep neural network that's been fine-tuned with a lot of effort and a lot of data and energy to make it do that response to the prompt come out as a very eloquent answer to a question. But remember that stochastic parrot, they're a parrot, they don't understand what they're saying. It's stochastic because the answers vary with a degree of randomness. Now, you take these algorithms, if you feed them text, you get things like ChatGPT and Bard and Llama and so forth. If you feed them images, you get images out. If you feed them code, you get programs out or code. If you feed them or train them on voice and music, you get voices and music out. You get videos out if you train on videos and so forth. In science, you can train them on things like DNA sequences, protein folding, all sorts of things, and you get them to address really hard problems in science, in chemistry, in many fields. What is ChatGPT itself? Well, that's basically a chatbot that's sitting on top of a large language model. So the chatbot takes the prompt, may make some adjustments to it, issues a query to the large language models, gets the result back. Typically, there's problems there. It might cycle, and then it provides the answer. That is trained, by the way, if we talk about ChatGPT in particular, I can tell you some of the statistics on GPT-3. This is about 2020. It's the last time OpenAI was open. After that, they stopped telling us what's happening. But up to GPT-3, they were very open about it. That's a 175 billion parameter model, meaning I take 1 terabyte of text data. And by the way, if anybody tells you that the training happened on all data in the internet. Not true. They tried that. It never worked. Why? Because the internet has a lot of contradictory information, inconsistent information, bad information, fake news, what have you. So they went after moderated content like Wikipedia, like New York Times, like scientific papers that are published, like books and so forth. And they used that 1 terabyte of data, which is a limited data set, to train the 175 billion parameters to come up with GPT-3, which was the first basis for ChatGPT. These were not new, and I remind you that they are basically autocomplete on steroids. An interesting question would be, well, how much energy does it take to train the 175 billion parameters on that 1 terabyte of highly curated data, right? And then the other question is, how much did it cost to curate that data, which was done manually and carefully, and it was balanced and so forth. The answer to the first question, one training session on GPT-3, ignoring the cost of hardware, ignoring any of the other things, just the electricity when you hit the train button on that 1 terabyte of data is $3 million of electricity. Of course, GPT 3.5 is more because that we think that's about 500 billion parameters. GPT-4 is even more. We think that's between 1.3 and 1.7 trillion. And now the talk is that it's going to cost over $1 billion, between 1 and 2 billion to train GPT-5. So the energy cost is huge of these things. And of course, this ignores the big cost of curating and balancing the training data. Why did it become so popular? Basically, it got so much attention because it went from 0 to 100 million users in 2 months. Compare that with Google Translate or Uber, which took over 70 months to get to the 100 million users. McKinsey has reports on what this is all going to be worth to the economy. It's in the trillions of dollars. I have a slightly different view on it, which is a view built on acceleration, right? Not automation, but acceleration. So there's several estimates that say acceleration can happen anywhere between 15% to 80% of the work in the knowledge economy. And if you ask what is the size of the knowledge economy for countries like the US, high income, it's anywhere from 35 to 54%. For the US, it's slightly over 50%. So even if it weren't 15% or 80%, even if it were 1% of the US economy, you can't ignore something that can cause speed ups of 1% for about half the US economy, which is a huge number. That's why economically, this technology matters, and its impact economically will be big. The impact on jobs, the human in the loop will remain essential. You need to check the output, you need to modify and edit it, and you need to approve it. This is so critical. And when we get lazy and we don't do this, we get ourselves in trouble. I often get asked the question, will AI replace my job? My immediate answer is no. AI will not replace your job, but a human using AI will replace your job if you're not using AI yourself. This, by the way, holds for individuals, holds for companies, organizations, what have you. So what I'll do next is basically give you a quick exposition of the evolution of generative AI over the past year, right? 2023 is when it got all our attention. So what happened over the past year that's new and interesting, right? Many developments happen, from kind of fascination to pragmatic evaluation. People are asking questions. It's no longer, a demo is no longer enough. What does it mean? How much acceleration does it come up with? How much speed up can I expect? How do you quantify the benefit, right? So take, for example, Microsoft Copilot for Code, right? Microsoft acquired GitHub for $7.5 billion in 2018. They had access to hundreds of millions of programs that they used to train the LLM to write code. I always thought, hey, writing Java or Python would be a lot easier than teaching natural language. Turns out that that's not quite right. Code is not easier than English. And the question is, how much productivity, for example, does it create? Also creates a very interesting answer. If we were involved in a couple of studies, if you are a very skilled programmer, this technology can speed you up between 60 to 80%. Let's call it 70% speed up. And that is significant. That means your market value just went up by 70%. What it also means, if you're not skilled, it actually turns out to be the case in a couple of these studies that you're better off not using the technology at all, because the skills you need to understand what gets output by the machine, parse it, be able to debug it and fix it and make it useful, ends up taking you way more time than writing the code from scratch. So that creates a bigger gap now between the lower skilled programmers and the higher skilled ones. It's effectively the rich get richer in this case, and the gap gets bigger. So with that, I'll do a case study in marketing using generative AI with customers. And the case study here comes from Virgin Cruises. Let's watch the video.
Hi, it's me, Jennifer Lopez, Chief Celebration Officer of Virgin Voyages, here to invite you to celebrate. So come, celebrate
Your anniversary, your birthday, or just generally being fabulous.
Really, Kyle?
It's good, right?
Gen AI is supposed to be inviting people to Virgin Voyages, not doing whatever that was. Just give me that. As I would say,
why not celebrate on an award-winning voyage with Michelin-starred chef-curated menus?
World-class destinations, award-winning.
Boring. I'll hop in there. I'll hop right in that suit.
I can't watch this. Give it to me. There's no kids here. That's all you need to know.
No kidding.
Oh, can I live there?
Gen AI. Invite your crew to voyage. Create your custom invite at virginvoyages.com.
It's not just a yacht, it's a super yacht.
So while this might seem like a fun example, it is a lot of real generative AI being used in the real world. They use generative voice to match the user's speech to J-Lo's speech patterns. If the basically users, people who book a ticket, get the option to send invites to their friends and family with a J-Lo video saying whatever message they ask her to say and moving like she moves. That turned out to be a very effective use that resulted in driving 1,000 additional ticket sales. Program was stopped for other reasons, but it's an interesting application. So having shared this example here and its impact from a marketing perspective, just wanted to say, look, you could have amusing applications of the technology, right? You can ask an algorithm, hey, render me a picture of an astronaut riding a horse in space. It's fiction. We all recognize it. It's fun, etc. The question then becomes, if the technology enables the generation of things like this, was the Pope really sporting these wild outfits? The answer is no. Did this arrest of President Trump happen? The answer is no. The point is, and of course, you could have deep fakes and deep videos, and that brings up a lot of concerns, because the bar, the degree of difficulty for generating something that looks very convincing and looks real just dropped dramatically with this technology. And this becomes a real issue, right? That brings up issues of fraud, impersonation, social engineering, cybercrime. How can you trust anything you see? What happens with human likeness? And especially when it's being done without transparency. So these bring up many important issues that we need to be thinking about, which brings us into this whole realm of responsible AI, which I believe is also an opportunity for our Commonwealth. We could take this need for responsible AI and all the dangers that come with AI and how to guard against them, and turn it into an opportunity for the state of Massachusetts. We'll come back a bit later to responsible AI, but in walking through the major developments over the last year, there's a lot of work on robustness and mitigating errors, RAG, or what's called retrieval augmented generation, which is really the way to think about it, is how do I take a prompt and an output and quickly do adjustments to those? How do I take a prompt and map it to something more normalized through doing lookups and through embeddings, get a better performance out of the large language model, a more accurate performance, and then check the output again and be able to modify it and extend the prompt. So the techniques now are maturing on how you change the prompt, how do you extend the prompt, how do you revise the prompt, and a lot of that falls under the area of RAG. There's different types of RAG now that are becoming very prevalent. The newest one is graph RAG, which is you represent kind of the knowledge you have to help adjust prompts and queries and so forth by utilizing a graph, which represents a knowledge graph. Larger LLMs are not necessarily better. Smaller LLMs can be more affordable, more stable, and of course, give you the chance of building your own private one where you don't have to rely on public large language models. So that narrowing of the specialization is becoming important. By the way, the tech giants are beginning to recognize this. For the past year, they've been pushing larger is better. Now they're actually recognizing that smaller could be smarter and more stable. I have a very quick case study here, which is with Bloomberg. Bloomberg published the details of a research project around building a Bloomberg GPT. They built a 50 billion parameter model to address problems like, I give you an article, the output should be, what is the headline describing the article? So you could say, okay, I consume the text and I'll say home prices see biggest drop in 15 years, or Yellen sees global economy more resilient, what have you. Then they use the same technology to say, hey, can we generate queries in the Bloomberg query language based on natural language questions? And sure enough, it actually performed really, really well. Same model, same technology. In fact, they actually built a domain-specific language to kind of handle many of these, which allowed them to come up with a capability that does sentiment analysis, auto-entity recognition, who, what, where, when, answering financial questions, summarizing articles reliably, and of course, the headline generation we talked about. So the question you might ask is, okay, why did they choose a 50 billion model, right? And the answer turns out to be, this is the largest model they can afford. And they were operating under the assumption, what's the largest number of parameters I can get away with and stay within the budget that management gave us? And they had about $3 million compute budget. Now, why am I telling you this story, right? And that led them to the 50 billion parameter model, which worked really well and achieved amazing performance. Well, a few months later, a small company called Stochastic AI comes up with a model called X-Finance. It matched the performance, but it was a 13 billion model that leveraged the pre-trained Llama model, right, from Meta. Their total spend on compute was $1,000 as opposed to 3 million, right? So that's an example of how these smaller models can be a lot smaller and more stable, a lot cheaper, and kind of show more robustness. So what does this mean for us? This, in the Commonwealth, well, this means we should ask questions. How much compute is really needed? How big do we need to make it? You know, we can't afford to compete with the big AI companies because they're spending billions of dollars on their clusters now, be it Andreessen Horowitz or be it any of the big companies. Meta just announced a ridiculously huge investment in NVIDIA GPUs to enable a lot of compute, which will enable them to do Llama, which is a great gift to the community because they're giving you pre-trained models in an open source license that you can use commercially. So the questions for us would be, well, how much compute do we really need? How do we make it easier to use? And how do we enable these quick starts to happen, which will enable our startups to happen faster, our companies to adopt the technology faster, easier, etc. And what is our angle for doing more with less, right? I'm a big believer that if we leverage the prior knowledge, the knowledge graphs and so forth, along with the learning, that enables us to come up with more efficient, more accurate large language models with a lot less needs for data and a lot less compute, right? So a question I like is, what is the smallest LLM I can get away with rather than what is the largest LLM I can get away with? And I think that's where if we invest in the right compute architecture and capability, we can enable a lot of stuff and allows us to use all the open source that's available out there for use. Ease of use and integration is becoming a big deal. Amazon Bedrock is an example of this. Multimodal interfaces, GPT-4o is an interesting one because now you can actually give it not just a textual prompt, but you can say, here's a prompt and here's an image, or here's a sound. Find something similar like this, or give me something in this style, and so forth. So they're making that real, and it's working fairly well for data that's well covered. Copilot capabilities are being integrated in Microsoft Office, in the browser, Windows, search, all of that. If you ask me what's a great example of an integrated Gen AI tool, my favorite these days is what Adobe did with Firefly. So what is this capability? Well, they built a private LLM, right? Which is, I think it was a very good decision. They used only images they fully owned. Over the past 40 years, they built up a library of images that they're fully owned by them, which then allowed them to indemnify users from any IP issues, which is a great thing, right? And then they integrated it in a natural way with a tool that's used by millions or tens of millions of people around the world, namely Photoshop. So what do? You get an image, you click somewhere and you say, hey, insert a classic car, put a pond there with the reflection. Oh, add a cloud that looks like the classic car, right? And these are kind of real examples. You naturally do them very quickly, you get an answer. So there's an example where they thought through many of the issues, including the IP issues, including the usage issues, including the integration. And that's a great example to learn from. Major developments, I'll end with kind of many developments on the technical front. We're seeing now large model agents. So a big agent that kind of understands the bigger task at a higher level, which sprouts smaller large language models that specialize in certain areas. I'll show you one example here. Student-teacher model, can an LLM teach another LLM and challenge it and so forth? Lots of interesting things, which led to synthetic data to overcome the fact that we don't have enough real data out there, and research to understand what happens inside the black box. Like these LLMs are really black boxes, how they work, when they don't work, why they make errors, all we don't understand at all, right? And investigating what happens inside is important. Here's an example of one of these kind of where you have a planning agent that sprouts sub-agents. This was used to identify, using GPT-4, autonomously hack zero-day security flaws. So in cybersecurity, a zero-day vulnerability is one that you don't know exists. It might sit there for a year or two in your systems. You don't know about it until it's discovered. That's day zero. So the question is, can you discover these more efficiently? And indeed, the system was built. It was 50% more efficient than a single LLM, and better than kind of humans trying to hack it. And way better than a single LLM. So they basically, this bigger planning agent sprouts a whole bunch of smaller LLMs that go after the hacks in parallel, one by one, and that's an effective one. A famous example there, I'm not going to play you the video, but you can, since you have access to the slides, of how to make a planning software engineer, right? That basically clones a whole bunch of models and builds tasks. Now, the demo looks amazing. The reality, of course, is much harder than the demo, and there's issues with it that people kind of challenged it. the thing got so good that the company claimed that they can leverage Upwork, pick up projects, and have Devin, this AI, do the work and get paid for it as a revenue source. I'm going to skip this. So with that, I just want to wrap up with responsible AI. A few things I wanted to say. LLMs do not hallucinate; they make errors. When we say they hallucinate, we're attributing too much intelligence to them. They're not thinking. They don't have a purpose. They don't understand when they're doing harm or not. They're just trying to answer questions, and therefore they can become very easy to manipulate into coming up with an answer to anything. Like, tell me how many times I should eat rocks to maintain my health, and it will come up with an answer. There's many issues in responsible AI, reputational costs, regulatory issues, and systems designed against society. We've come up with a framework that allows us to think about the risks at the ideation stage, at the design and development stage, during the operations, and when it fails, understanding what happens. Of course, when it harms, well, that's now down to the courts and problems and so forth. We also assembled an international ethics board of 40 plus people that Northeastern, the Institute uses to kind of help our partners kind of address some issues they have. There's a public case study by Verizon. I encourage you to read about it. It's available on our website. But as an example, Verizon got so excited about this that they said, hey, we want you to hire an ethicist, an embedded ethicist by the Institute, but dedicate that ethicist full time to work with Verizon on their projects. And that, we leveraged in that project our approach to governance, product and project ethics analyses, and the skills and the training. Concluding remarks, generative AI offers the means for accelerating work, but not fully automating it. It can help reduce robotic, repetitive, and manually intensive work. It can be a game changer for efficiency, accuracy, and customer experience, of course. National regulation is coming. It already came in the EU. It'll come in China, then probably the US will follow. And the barriers are coming down, especially if you do it rationally. The last message I leave with you is no data, no working AI. So data is extremely important, and human intervention right now is still a must. And so we need to figure out how to capture the data from the human interventions and leverage them on an ongoing basis. And there's a rational approach to building this, and I think it's a great opportunity for the Commonwealth to kind of make such an approach available and come up with the regulation to enable it. With that, this is my contact information. I encourage you to get in touch. We're sharing the slides, and I'm happy to kind of point you to more detailed talks and so forth if you're interested. So with that, I will stop the share. I thank you for listening, and happy to deal with questions and or meetings and or follow-ups as interested. Thanks, everyone.